Hello everybody, it's been a while since I've made one of these, and this is probably going to be the most important geometry video you could ever watch to prepare for your Geometry Regents exam. This is the version without proofs. I will create a separate video for the one that is all proofs. So let's get right to it. Triangle ABC and point D. Triangle ABC and point D are graphed on the set of axes below. Graph and label triangle ABC prime, the image of triangle ABC after a dilation of scale factor 2, centered at point D. So to dilate a shape, I'm going to count from the center of dilation to each point. I'll start with B. Left 1, up 3. I'm going to do that the scale factor number of times. So left 1, up 3, 1. Left 1, up 3, 2. That's B prime. Now I will do it for A. Left 3, down 1, 1. Left 3, down 1, 2. And for C, right 3, down 3, 1. Right 3, down 3, 2. There's my C prime. I connect them with a straight edge. And that is how I dilate a shape centered at a point that is not the origin. Next, if the center is the origin, there's a nice shortcut. And if you're centered at the origin, all you have to do is multiply the scale factor and the coordinates. Later on, we talk about line dilations. It's going to be the same thing where we're going to multiply by the scale factor to find the y-intercepts. But we're not there yet. We have a lot of awesome things to do between now and then. So if I'm dilating centered at the origin, I'm going to list the coordinates. A, B, C. A is negative 2, comma 1. B is 0, comma, looks like 4. C is 4, comma, negative 1. I'm multiplying by 2, so I get negative 4, 2, 0, 8, 8, negative 2. Negative 4, 2 is A prime. 0, 8 is B prime. 8, negative 2 is C prime. I connect them with a straight edge, and there's my dilation. So if I'm dilating a shape, if the center of dilation is the origin, I'm multiplying the scale factor and the coordinates, and if the center of dilation is not the origin, I'm counting from the center of dilation to each point the scale factor number of times. To do a reflection, we count to what we're reflecting over. X equals 1. Well, Yancey has X-ray vision. Y equals a number is a horizontal line. X equals a number is a vertical line. That's going to come up in multiple topics. So X equals 1 is a vertical line at 1. A little bit off. Let's fix that. And I'm going to count to what I'm reflecting over. So let's start with B. To get to what I'm reflecting over, I'm going 1 right, so I go another 1 right. That's B prime. C, I go 1 right, I go another 1 right. And A prime, it's 1, 2, 3, 4. 1, 2, 3, 4. That's A prime. Connect them with straight edge. Is it asking me for the coordinates? No, I'm done. So to reflect, I count to what I'm reflecting over. The one rule I'd like you to have memorized, I don't think I put it on the test here, no, but if you're reflecting over y equals x, well, y equals x is y comma x. You're just switching the coordinates. That's really the only rule I want you to have memorized for reflections in case you need to do it. So One thing I didn't put on the test, I put in the review though, the rotation rules. Let's just talk quickly about the rotation rules. 90, 180, 270. These are positive counterclockwise rotations. 90 is negative yx. 180 is negative x, negative y. And 270 is y comma negative x. And these will come up. And again, these are for the positive counterclockwise rotations. If I'm going clockwise, then it's the opposite. So if I wanted to go 90 degrees clockwise, that would be the same as 270 counterclockwise. And if I want to go 270 clockwise, that would be the same thing as 90. So that will come up. So number 4, on the set of axes below, triangle LET and LET double prime are graphed in the coordinate plane. Which sequence of rigid motions will map one onto the other? Identify the transformations. Translate, rotate, reflect, check for orientation. Whenever you're identifying transformations, start by checking for orientation. The only one that changes orientation is a reflection. A single reflection will change orientation. So this one is going clockwise. This one is going counterclockwise. The orientation is different, which means there must be a single reflection. So I'm going to look at the choices. Choice 1, double reflection, no. Choice 2, a single rotation, no. There must be a single reflection involved. A rotation and then a reflection, it could be that. A reflection and then a rotation, it could be that. So I'm down to choices 3 and 4. And unfortunately, I don't really have any shortcut for you here other than to pick one, do it, and see if it works. So I find it's easier to, you know what, I'm going to be nice for myself. I'm just going to jump to the answer. So choice 3 was the answer. So I'll just go through choice 3. I'm going to clean this up a little bit. A rotation of 90 degrees counterclockwise. So I'm going to do a rotation of 90 degrees counterclockwise. So I'm starting with LET. So I have LET. L is negative 3, 6. E is negative 1, 3. T is negative 5, 1. And I'm doing a rotation of 90. Well, 90 is negative yx. So that's negative 6, negative 3. Negative 3, negative 1. Negative 1, negative 5. I plot those. Negative 6, negative 3. That is my L prime. Negative 3, negative 1. That's my E prime. Negative 1, negative 5. That's my T prime. I mean, I can draw it in if I want. Followed by a reflection over the y-axis. And yes, 1, that goes there, that goes to there. That is correct. If you went through choice 4, it wouldn't work. But again, check for orientation to eliminate choices. These used to be easy. They're hard now. You're going to have to go through and you're going to have to be able to perform the transformations. But once you check for orientation, you'll at the very least be able to eliminate probably 2, if not 3 of the choices. If triangle ABC prime is the image of triangle ABC, which transformation will the triangles not be congruent? Listen, there's not many easy questions in this geometry regents. This is one of them. They all produce a congruent figure, except for dilation. So if it ever wants to know which one's not congruent, it's a dilation. They all preserve size, except for dilation. They all preserve orientation, except for a single line reflection. After reflection over a line, triangle ABC prime is an image of triangle ABC. Explain why the triangles are congruent. Well, we already said, identify the transformations. Translate, rotate, reflect, check for orientation. I don't have to do that here. It tells me that it was a reflection. State that it's a rigid motion. A reflection is a rigid motion. Tell me what that means. A rigid motion preserves size and angle measure. Pause. Got to catch up. Producing a congruent figure. Memorize my songs. I'll put a link to my song page in the bottom here. If you think you're too cool to learn my songs, well, you're probably right. But if you want, high Regents grade, you don't need to be cool for a high Regents grade. That's it. This one kind of incorporates two of the things we just did. As graphed in the set of axes below, triangle ABC prime is the image of triangle ABC after a sequence of transformations. Identify the transformations. Translate, rotate, reflect, check for orientation. This one is going clockwise. This one is going counter. The orientation's different, so there must be a reflection. So use a little bit of geometric common sense as far as what you're reflecting over. Y-axis seems pretty obvious, so I'm going to reflect triangle ABC over the y-axis, and I'm going to do the reflection. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 1. Followed by, well, now that I did the reflection, it's pretty clear to see what I need to do next. A translation down 3 units. Are the triangles congruent? Well, yes. State that it's a rigid motion, a reflection, and translation are rigid motions. Tell me what that means. A rigid motion preserves size and angle measure, producing a congruent figure. I'm not writing it again. Just not going to happen. If you want me to, well, that's too bad. This would be a 4-point question. It's generally 1 point, 2 points for identifying the transformations, and it's 2 points for explaining why they're congruent. You might just see the identifying, you might just see the explaining, or you might see them both together. Same thing, check for orientation. This one is going clockwise. DEF is also going clockwise. So since the orientation is the same, it is not a reflection, which means it's going to have to be a rotation. So we got to use a little bit of geometric common sense as far as how much we're rotating it. We want ABC onto DEF. It looks like it's going 90 degrees clockwise. I don't like clockwise. I like counterclockwise because I know my rules for counterclockwise. So I'm going to rotate triangle ABC 270 degrees counterclockwise, centered at the origin. All my rotation rules are centered at the origin. So now I'm going to do it. Let's just clean this up a little bit. Let's find a fun new color. Fantastic. So I've got A, B, C. A is -1, 5. B is negative 1, 1. C is negative 3, 1. The rule for 270 is y negative x. So 5, 1, 1, 1, 1, 3. Plot the new points. A prime, B prime, C prime. Now that I did the rotation, followed by a translation, so it's 1 right and 1, 2, 3, 4 down. Is it asking anything about congruence? No, I'm done. If it said, are they congruent, or explain why they're congruent, it would be yes. A rotation and translation of rigid motions. A rigid motion preserves size and angle measure, producing a congruent figure. Do these steps, all right? Some of you that I tutor maybe, some try and do some crazy stuff in your head, man. Just do the rotation with the rules, lay it out the way it's supposed to be done. Don't lose points necessarily. The regular polygon below is rotated about its center. So, minimum rotation. Min rotation is 360 over n and any multiple of that. That's the tail end of the song, which incorporates this. And the next type of question, this thing has 1, 2, 3, 4, 5 sides. So I start with 360 over 5. That's 72. That's the minimum rotation. Any multiple of that will also map it onto itself. And 72 times 3 is 216. Line of that's not right. Line of reflection equals line of symmetry. Center rotation equals center of shape. I don't know what's worse, my handwriting or my voice. These are your two rules for mapping a shape onto itself. For reflection, the line of reflection must be a line of symmetry. And for rotation, the center of rotation must be the center of the shape. You have to use a little bit of geometric common sense as far as your degree measure. Which transformation would not map the rectangle onto itself? Well, x-axis is a line of symmetry, so that will map it onto itself. X equals 4. Again, Yancey has X-ray vision. That's a vertical line at 4. Not the straightest line, but is that a line of symmetry? Yes. That leads me with two rotations. Center rotation equals center of shape. 4, 0, center of shape. 0, 0, not center of shape. That will not map it onto itself. Are we done with transformations? Kind of. This is kind of the bridge. After a dilation with a center, blah, 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 blah. Scale factor. You need to know that scale factor is equal to image over original. There's a lot of different ways they can ask a scale factor question, but it's going to always be the image over the original. It has to either tell you what the image is, or in this case, the image is the primes. So it's going to be 18 over 4.5, which is 4. Keep in mind, you can also write scale factor with segments depending on the question. So this would also be the scale factor. However, it's not one of the choices, so you'd have to be able to do it numerically there. Scale factor is always the image over the original. CD is 6.6. DE is 3.4. CE is 4.2. BC is 5.25. AC, always put an X on what you're trying to find. Now, it doesn't say that these triangles are similar, but they are. They're giving you enough information to determine they're similar. When they say that these are parallel, it makes your alternate interior angles congruent. I don't want to confuse you with any of that right now, but it's safe to say when you see these twisted rotated triangles that they're similar. So when you have similar triangles, the corresponding sides are in proportion. So just be careful, since A and D are going to correspond, the opposite segments are going to be the ones that correspond. So X is going to correspond to 6.6, and 5.25 is going to correspond with the 4.2. And it doesn't matter which triangle you start with, but if I do left over right, I have to do left over right. From here, I cross multiply and solve. 4.2x equals, I'm going to use my cheat sheet here because I'm not going to bust out the calculator for all these calculations. 34.65 divide by 4.2, and x equals 8.25. So for similar triangles, the sides are in proportion. We create a proportion. And when you have this specific picture, which is a pretty common picture, just make sure that you know that the corresponding sides are kind of twisted. Midpoints, midpoints, midpoints. The rule for midpoints, 2 times the midsegment is equal to the opposite side. A lot of little rules in the similar triangles unit. So if AB is 20, let me use different colors for this one. If AB is 20, FE, this midsegment must be half of that, which must be 10. If BC is 12, then this midsegment must be half of that. And if AC is 16, then this midsegment must be half of that. So now it's asking me for the perimeter of trapezoid A, B, E, F. So we want to outline the shape. And since this whole thing here is 12, this is 6. And since this whole thing is 16, this is 8. So the trapezoid would be 8 plus 10 plus 6 plus 20. And that's 44. Same thing, but now we have some algebra. So AC is x plus 15. DE is x minus 3. Again, because these are midpoints, it has to say that they're midpoints in order to use this rule. 2 times the midsegment is equal to the opposite side. So it will be 2 times the midsegment, x minus 3, is equal to the opposite side. From here, we do a little bit of algebra. Not a lot of algebra in this course, but a little bit of algebra in this course. Bring all the x to one side. Isolate. X is 21. Once I solve for x, we want to make sure we answer what the question's asking for. It wants DE. Well, DE is x minus 3. So DE is 21 minus 3, which is 18. I think I know what's coming next. I think it's going to be a song. Candy corn, bases separate. Are the bases involved? So I call these candy corn problems because they look like candy corns, those disgusting candies you get around Halloween time. Are the bases involved? Yes, the bases are the parallel sides. If the bases are involved, separate the triangles. A, C, B, D, E, D. Put the information into both pictures. The small one's the easiest one to start with. DB is 12, DE is 4. AB is this whole thing, which is 36. Expect to have to add or subtract pieces. AC is x. Now we put our corresponding sides on top of each other. I'll go x over 4. I'll go 36 over 12. We cross multiply and solve. X is 12. Always put an X on what you're trying to find, TR. Candy corn, bases separate. Are the bases involved? No. If there are no bases, put the top over top, the side over side, and the bottom over bottom. Expect to have to add or subtract pieces. It's easier if you do it at the beginning. Since that top is 2 and the bottom is 4, this whole thing is 6. Do I have both tops? I've got a 2, I've got a blank. Nope. Do I have both sides? I've got a 6, I've got a 9. Yes. 6 goes over 9. Do I have both bottoms? I've got a 4, I've got an X. Yes. Cross multiply and solve. 6x equals 36. Divide by 6, divide by 6. X is 6. Could I have separated the triangles? Yes. You would have ended up with a 9 minus x or something like that, which is kind of nasty, which is why if the bases are not involved, it's easier to just put the top over top, the side over side, and the bottom over bottom. This is not super commonly asked, but it has come up multiple times. It's overlapping similar triangles. I'm going to definitely want to separate them. So I'm going to draw my big one, my CHR, and I'm going to draw the small one so that it looks the same as the big one. So I'm not going to draw it like it looks here. I'm going to draw it like the big one. The tricky part is getting the letters in the right spot. How do you get the letters in the right spot? Well, I got you. Here's how. It's telling us that angle H is congruent to angle D. That means that angle H must correspond to angle D. So D is going to go there. You almost always have a reflexive angle in this type of problem. R is reflexive. R is in both triangles, so R is going to correspond to R. What's the only letter left in the small triangle? O. Put the information into both pictures. Exclamation point. RD is 4, RD, RD, RO is 6, 6, 6, OH is 4, 4, don't see it in the big triangle, CD is X, don't see it. Since I labeled my big triangle though, I know that HR must be 10, and I know that CR must be X plus 4. Now I have my corresponding sides. I create a proportion. I'll go x plus 4 over 6 equals 10 over 4. Cross multiply and solve. 4 parentheses x plus 4 equals 60. 4x plus 16 equals 60. Minus 16. Algebra is fun. Divide by 4. X is 11. I have some Hill-Sass coming up? Yeah, I do. Hill-Sass. Every Regents, you're going to see a Hill-Sass problem. So, it looks like a big hill. This one's kind of turned on its side, but whatever. Always put an X on what you're trying to find. Hill-Sass. If there's an L involved, use Hills. If there's an A involved, use Sass. There's an L involved. The A is blank, therefore I'm using Hills. H, this whole thing is H, 15 over L is X equals L is X. It's going to always be the same value in the bottom left and top right for both Hills and Sass. And since I'm using this leg, I'm using this seg. Once I have my proportion, I cross multiply and solve. Square root, now it's very likely you're going to have to reduce a radical. They haven't been reducing radicals as much recently, but you might have to. Perfect squares and non-perfect squares. I'm not going to teach you a lesson right now on reducing radicals. If you don't know how to do reducing radicals, find my video on it. 3 radical 5. It's in my similar triangles unit. There's like a lesson. It's like Algebra 1 for geometry. I went over reducing radicals. I went over solving quadratic equations. And I went over in terms of x. This question can be really hard or it can be really easy. This picture stinks. I do not like this picture. I cannot see what corresponds to what, so I'm going to draw my own triangles. Doesn't matter how I draw them, as long as I order the letters the same way. So if ABC is left, top, right, then DEF is left, top, right. Now that I did that, it's pretty hard to get this wrong. BC, DE, do those correspond? No. AB, DF, do those correspond? No. Angle C, angle E, do those correspond? No. Running out of letters here, colors here. Angle A, angle D, yes, they correspond, so those must be congruent. If they give you these similar triangles, they give you these horrible pictures, just cross them out and draw your own picture. Just follow the letters in the same order in which they're given. This becomes a very easy question. Similar thing, but different here. Similar, it's a little pun here because now I have similar triangles, but these triangles stink, so I'm going to draw my own. Q, R, X, and TUV. Now, to determine if a proportion is correct, here's the little Schlansky trick. Look at the letters horizontally. Look at the letters vertically. One direction should correspond. One should be in the same triangle. QR, QX. They're in the same triangle. That's good. That means this direction should correspond. Do QR and TU correspond? Yes. This proportion is good. It says which is not true. So now let's pick a different color. XQ, same triangle. XV, XV, they correspond. That one's good. RXVT, RXVT, they don't correspond. They're not in the same triangle. That one's out. And finally, QXTV, they correspond. QX, QR, they're in the same triangle. That one works. Which one is not correct? That one. More bad pictures. Draw your own. RST, XYZ. RS is 6, ST is 14, XY is 9, YZ is 21, angle S is congruent to angle Y. Are the triangles similar? Well, there are 3 methods to determine if triangles are similar. There is, this thing just freeze on me? Let's try that one more time. Or am I frozen? And we're back. Like it never happened. Okay, I think we are okay now. My computer does not like me. All right, so I'm still going to try and blow this up. Good. So there are 3 methods for showing triangles are similar. There's AA, SAS, SSS. The A's mean that corresponding angles are congruent. The S's mean that corresponding sides are in proportion. So AA, 2 pairs of corresponding angles are congruent. SAS, 2 pairs of corresponding sides are in proportion, and the angle between them are congruent. SSS, 3 pairs of corresponding sides are in proportion. So based on the information we have here, the only possible method would be SAS. Now, because I have 2 pairs of sides and the angle in between them. Just because I have some sides labeled doesn't make the triangle similar. I have to determine if the sides are in proportion. So I put the corresponding sides on top of each other. I put 6 over 9. I put 14 over 21. It doesn't matter which one I start with. 6 over 9 reduces to 2 over 3. 14 over 21 reduces to 2 over 3. If you can't reduce fractions because you don't know 6th grade math, that's okay. I got you covered. Just go to your calculator. Alpha y equals enter, or alpha x for those of you cool enough to have the colored edition. That reduces to 2 over 3. Alpha y equals enter. 14 over 21. 2 over 3. So, yes, They're similar. The short answer is because SAS. If you wrote because two pairs of corresponding sides are in proportion and the angles between them are congruent, that's awesome. That's not going to happen for most of you. If it does happen for you, good for you. All right, this might be the most important thing going into the Regents exam to know. 10% of your exam will be right triangle trig SOHCAHTOA. Always put an X on what you're trying to find. The length of the ladder. Whenever a ladder is leaning against a house, this is your ladder. And always put an X on what you're trying to find. It wants the length of the ladder. Step 1, label your H, your A, and your O. H is always the hypotenuse, the long slanted side, opposite the right angle. The angle always connects the H to the A, so this arc will always touch the H and the A. The opposite side is my opposite side. So, SOHCAHTOA. Out of the H, the A, and the O, which two are involved? Well, the O is 30, and the H is X. Since O and H are involved, we're going to be using sine. So sine of theta equals O over H. Sine is 70. Theta is always the angle. O is 30. H is X. Since X is in the fraction, I cross multiply and solve. X sine 70 equals 30. Divide both sides by sine 70. X equals, this is when I will pull up the calculator just to make sure you know how to type it in. Make sure you're in degree mode. If you're not in degree mode, you're going to have a bad day. You're going to have a real bad day if you're not in degree mode. So please make sure you're in degree mode. I got 30 over sine 70. So I'm going to go alpha y equals enter. 30 over sine 70 is 31.92 whatever. It wants me to round to the nearest foot. So that's going to be 32. What is the measure of angle A? Well, it's a right triangle. There's an angle involved. Therefore, I'm going to be doing SOHCAHTOA. We start the same exact way as the last one. Label your H, your A, and your O. Out of the H, the A, and the O, A and H are involved, so it's cosine. Cosine theta equals A over H. Theta is the angle, which in this case is X. A is my 9, H is my 14. Now, I want to get X by itself. X is not in the fraction, it's almost by itself, but I got this pesky cos in front of it. No, I can't divide by cos. To get rid of the cos, I do inverse cosine of both sides. That gives me inverse cosine of 9 over 14. To type in inverse cosine, I hit second cosine. Alpha y equals enter, or alpha x for those of you who are cool enough to have the colored. I got to the nearest degree, 50 degrees. Now, there's going to be I can almost guarantee you there's going to be a 4-point compound right triangle problem. And I can say that half of those, there's a 50% chance it's going to literally be this exact picture with this exact procedure. If it's not, you have to just kind of wrap your head around the situation, do the best you can. Measure of angle CAD is 35. Was I smart enough? No, I wasn't smart enough to make this bigger. That's okay. CAD is 35. ABD is 42. AD is X. I'm sorry, AD is 60. And it wants BC. Your go-to should be subtraction. Can I subtract two things to find BC? Yes. So I'm going to draw both right triangles. I'm going to draw CDA. And I'm going to draw BDA. So the small one first, this is 35, this is 60, and I'm finding the bottom. And for the big one, I've got a 42, I've got 60, and I'm finding the bottom. So, H, A, O, H, A, O. This one is A and O, tangent. This one is O and A as well, tangent. Theta is 35, O is X, A is 60. Theta is 42, O is 60, A is X. Since I'm finding the side, since X is in the fraction, I'm cross multiplying. X equals 60 tan 35. X tan 42 equals 60. In this case, I have to divide by tan 42. So I've got 60 tan 35, 42 dot dot dot. We do not want to round until the very end, so I'm going to write dot 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 because I'm not cruel and making you write out all those digits. 60 over tan of 42, 66 dot dot dot. So this whole thing is 66. This is 42. So to find that missing piece, I'm going to do my 66 dot 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 minus my 42 dot dot dot. I'm going to copy and paste those. That minus that 24 point whatever. Now, since I'm done, I can round to the nearest tenth, 24.6. If they give you this picture, it could be an angle, it could be a side, but like half of the time, it's literally doing that exact procedure. If it's not, you gotta you're gonna be doing SOHCAHTOA. It's possible Pythagorean theorem could be mixed in there, and you just have to kind of wrap your head around the situation. This is an example of one that isn't. I kind of wanted to take this example off because they really only asked this once, but I'll do it because, you know, cool like that. As cool as someone can be that's choosing to spend hours making a geometry video for the internet to see. So it's asking for, there's a lot of stuff here. It's asking for the campsite to the tower. It's asking for this. So this is a side of the big right triangle. I can't find it by subtracting, so the procedure I just did is not going to work. I don't have any other information for the right triangle. I have this angle 55, but I don't have another side. So I'm going to look for a reflexive side. I'm going to look for a side that's in both the big right triangle and the small right triangle. And that reflexive side is this one. So I'm going to find that side using the small right triangle. So I've got my H, my A, my O. I've got the A involved, I got the O involved, so I'm using tangent. So I'm doing tangent of theta equals O over A. Tangent of 72 equals Y over 400. It's a side, Y is in a fraction, so I cross multiply. Y equals 400 tan 72. You've seen how to type this into the calculator enough, so I'm not going to keep on going to the calculator. Save a little bit of time here. I got 1231 dot dot dot. So I'm going to put that into the picture. And now that I have that, it might help to redraw the big triangle if this is starting to look a little messy. So this is 1231 dot dot dot. This is 55. This is X. H, A, O. O and H are involved. So it's sine theta equals O over H. Sine of 55 equals 1231 over X. cross multiply x sine 55 equals 1231 dot dot dot. Divide by sine 55. Pop it into the calculator. X equals 1503 rounded to the nearest integer, or whatever it said to round to, nearest foot. So, like, on my review, I say always look for subtraction first. If not subtraction, look for reflexive. And yes, that would help you for this question. But I'm really racking my brain. I really can't think of another Regents question where you had to use reflexive. But whatever. All right, here we go. The song that almost got me fired from a tutoring center because it was so amazing. Girls started singing and dancing. There were noise complaints. It was bad. Sine A equals cosine B. A plus B equals 90. Sine of one acute angle is equal to cosine of the other acute angle, and the angles themselves have to add to equal 90. Now, it doesn't have to be the letters A and B, although it usually is. Recently, they've been using different letters, which is nice. But what it does have to be is the acute angles. So if angle C is the right angle, it's always the other ones. It's not the right angle. Sine A equals cosine B. So if cosine B is 5 over 13, then sine A is 5 over 13. Sine A equals cosine B. Now here's where it gets tricky. I see sine A equals cosine B. Does it say sine A equals 2x plus 7? No, it doesn't say that. If it said sine A equals cosine B equals, then we'd set them equal. A is what comes after sine. A is 2x plus 7. B is 4x minus 7. And A plus B equals 90. So if it's ever sine of something equals cosine of something, those somethings are A and B, and A plus B equals 90. So 2x plus 7 plus 4x minus 7 equals 90, and we solve the equation from there. 6x equals 90, divide by 6, divide by 6, x is 15. Every Regents, you're going to see either this or this. All right, so this upsets me because I'm not, you don't see me right now, and I don't think there's any way to correctly teach cross-sections without physically seeing me, and I use Play-Doh. So if you don't understand this, please consult my video on cross-sections. So we've got Schlansky.com. We've got Common Core Geometry Worksheets, volume and three-dimensional objects. Watch the cross-sections lesson. If I play it right now, it's going to look really choppy. But you really need to just see what the cross-sections look like by actually cutting something. Now, for those of you who are good spatially, great. But if you're not good spatially, then use Play-Doh, and you can watch that video, or you can say, if you actually work with me, if you're one of my students or one of the kids I tutor, you can say, Mr. Schlansky, can you please bust that Play-Doh out, because I still don't understand cross-sections. First off, perpendicular to the base is always vertical, and parallel to the base is always horizontal. So if I have a hexagonal prism, which I don't even want to try and draw, I don't even want to do it. Should I do it anyway? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Something like that. If I'm going perpendicular to the base, then I'm cutting it vertically. If I take a vertical slice out of any prism, since a prism is congruent shapes connected by rectangles, the cross-section is going to be a rectangle. If I cut it parallel to the base, it would always be the base, which would be a hexagon. So if you don't feel comfortable with cross-section, I would just watch my cross-sections video. But a cross-section is a two-dimensional slice from a three-dimensional object. I'm not going to insult you by saying that I'm a good teacher who can teach you how to do a cross-section by talking about it or putting something on a blackboard. No, you need to actually see the shapes, watch it being cut. If your teacher did not do that, well, that's unfortunate. And I'm probably the only teacher that actually does do that. So if you do have me as a teacher, let's take advantage of that and get a good Regents exam. Great. Volume. Volume equals the area of the base times the height. Let's talk about our volume formulas. Most of them are given to you you get that stupid B on that reference sheet. So in general, volume is always the area of the base times the height. So for rectangular base shapes, you're going to have length times width times height. And for circular base shapes, you're going to have pi r squared times the height. If it comes to a point, 1/3 goes in front of it. So a pyramid would be 1/3 length times width times height. A cone would be 1/3 pi r squared height. So this stuff is on the reference sheet for the most part. But on your reference sheet, when it says 1/3 BH for pyramid, I mean, screw that, man. Do not do it. Cross that out. It's 1/3 length times width times height. They're not going to give you a triangular base pyramid. They're not going to do it. If they do, say, Mr. Schlansky, you cost me 2 points. And I'll say, all right, that's too bad. Move on with your life. So be careful with your formulas. Some of them are on there. Some of them aren't quite on there. Rectangular prism just not on there. I don't know where New York State decides what they arbitrarily want to throw on there or not. But know your volume formulas. I'm not going to write them all up here right now. You can watch my volume video if you want them, or just look at my big packet, which is posted on Schlansky.com. Sphere is the exception. For a sphere, there's no base. So this is given to you in the reference sheet. There's no issue. 4/3 pi r cubed. Diameter is 8, which means the radius is half of that, which is 4. Phi equals 4/3 pi 4 cubed. If it says in terms of pi, type pi in. If it doesn't, don't. Alpha y equals enter. I don't know why I'm doing this. I should probably just pull the answer off my sheet, but whatever. Pi 4 to the power of 3 to the nearest hundredth, 268.08. So you're responsible for all your shapes: rectangular prism, cylinder, cone, pyramid, sphere. You can cut those shapes in half and get half of a sphere or half of a cylinder, put a half in front of the formula. A general prism in general is area of the base times the height, and triangular prism is area of the base times the height. 1/2 base times height of the triangle times height of the prism. If they give you the volume, we start the same way. Volume of a cylinder. Well, volume of a cylinder is pi r squared h. Since the volume is 12,566.4, I put that in for V. The height is h. And now I have to do a little bit of algebra. I actually learned something today, a little trick in the calculator where you don't have to do this algebra, but I'm not ready to bust it out yet. So you can ask me about that. If you can't do this algebra, you can ask me about how we can do this without knowing how to do algebra. 12,566.4 over 8 pi is 500 dot dot dot. I don't want r squared, I just want r, so I take the square root of both sides. Second radical, second answer, 22.4. That's the nearest term. All right, we're moving along here. This is a pretty obscure question. I mean, is it a commonly asked question? No. It's been asked, I don't know, 3 times maybe. Population density. So there's density, there's population density. DMV, TD-POV. Density equals mass over volume. Population density equals population over area. So I've got town A. I've got town B. You may need to calculate the area. this one is giving to you. So town A has an area of 12. Town B has an area of 10. Town A has a population of 8198. Town B, 7384. We divide them. Let's see if I can just find my sheet. Yep. So I got for town A, 683 dot 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 738.4 dot dot dot. Town B has a greater population density. Regular density equals mass over volume. Start by finding the volume. This is a rectangular prism, a brick. It's assumed to be a rectangular prism. Length times width times height. 4 times 3 times 8 is 96. So density equals mass, 1824 grams, over volume, 96 cubic centimeters. Divide them, and you get 19 grams per cubic centimeter. And I guess I should have put units here. People per square mile, for those of you who want to be really particular. Because density without units doesn't really mean anything. So that would be that. 3D rotations. Now, this is something that is really nice to see in real life. However, you can do 3D rotations on paper. I don't think most teachers know that. If I want to continuously rotate the right triangle around AB, step 1, reflect the triangle over AB in 2 dimensions, and then connect it with curves. Once I have that, in this case it's asking for the volume. Well, I have a cone, so I'm going to write my formula for the volume of a cone, which is on the reference sheet. I'm going to carefully sub my values in. The radius is 4. The height is 6. It wants the answers in terms of pi because there's pi's in the answers, so that means I'm not going to type pi in. I'm going to go alpha y equals enter, 1/3, 4 squared times 6. I got 32 pi. I feel like our modeling stuff's coming up here, isn't it? Am I frozen again? I was just thinking I haven't been frozen in a while. Oh, nope, not frozen. Oh, maybe frozen. Let's just give this thing a moment. I think this thing hates me. Yes. So, you're going to see a 4-point question, modeling volume. I can almost guarantee you that. I can prepare you for the straightforward. I can prepare you that you're going to have to find the volume, and you're going to have to do unit analysis or dimensional analysis, whatever you want to call it. From there could be twists around that. I can't control that, but I can control you knowing how to do volume and then taking that volume and doing unit analysis. So, I've got 2 shapes here. I've got my hemisphere. I got my cone. I didn't even bother reading anything. I know that I'm going to have to start by finding volume. So my hemisphere is 1/2 4/3 pi r cubed. Half of the sphere. That's ugly. And my cone is 1/3 pi r squared h. The radius is half of the diameter. You can use the calculator. It's 4.15. So it's 1/2 4/3 pi 4.15 cubed. And the cone has the same radius, 4.15 squared, 10.2. Make sure your units match. They do here, centimeters, centimeters, cubic centimeters. If they don't match, you're going to have to first convert units to whatever's coming later in the problem. We pop them into the calculator. Again, I'm going to cheat off of my sheet here. You don't need to see me type this in. The hemisphere, I got 149, dot, dot, dot. The cone, I got 183, dot, dot, dot. So to find the volume, I'm going to add them together. and I get 333 cubic centimeters. So what I'm going to do is I'm going to erase all this now. Actually, let me see if I can do this by expanding the screen. Yeah, this will work. So now that I have my volume, I begin unit analysis. I'm starting with cubic centimeters. I want to ultimately get to cost. So I want to get rid of cubic centimeters. So I'm going to write cubic centimeters on bottom, and I'm going to look through the problem for cubic centimeters. Boom. Cubic centimeters is changing to grams. 0.697 grams is 1 cubic centimeter. Cubic centimeter is gone. I'm going to cross that out as well. Now I have grams. I want to get rid of grams. So I'm going to look for grams. Will I see kilogram? Another little twist. To get from grams to kilograms, you need to know your metric conversions. 1,000 grams is 1 kilogram. Grams are gone. I've got kilograms. I'm going from kilograms to money. And it's 383 with the money for 1 kilogram. Kilograms gone. I want cost. I have cost. Finally, is there a quantity or a percent? Yes. So I multiply by the quantity. If it was a percent, like 60%, I would multiply by 0.6. I typed this whole thing into the calculator using alpha y equals enter, and I got my answer of 4453. I consider this the second hardest thing on the Regents. This question is pretty straightforward. Even so, I probably still call it the second hardest thing on the Regents, the hardest thing being the parallelogram proofs, which are commonly a 6-point questions. So it definitely takes time to practice, but this is a very straightforward version of it. There can definitely and probably will be twists along the way. This I just added on because since the pandemic, 2 of the 3 exams have had this concept of like packing things into a box or a shelf. So I feel like we need to address that. First off, the first thing to do is check my units. My units do not match. I got feet, I got inches. Later on in the problem, I see inches, so I need to make everything inches. So I'm going to take my 2 feet and convert it to inches. 12 inches in 1 foot. That's 24 inches. You might be saying, Schlansky, I know that there's 24 inches in 2 feet. Good for you. But if you don't, then this is what you're going to do. 12 inches, 1 foot, 12. So a packing box. So right now, I'm going to start by making this packing box. It's 2 feet, so that's 24 by 12 by 18. Each baseball, we're putting baseballs in this box, and each baseball has a diameter of 2.94 inches. And again, this is all inches. Determine and state the maximum number of baseballs that can be packed in a box if they are stacked in layers, and each layer contains an equal number of baseballs. I can't cut the baseballs in half. So what I'm going to do is I'm going to divide. I'm going to start with this 24. I'm going to see how many are going to fit across this way. So I'm going to divide 24 by the diameter of the baseball. Since the diameter of the baseball is how much horizontal space that it's taking up. I got 8.16 ... So let's put this onto paper here. 24 divided by 2.94. I'm going to do 12 divided by 2.94 for that dimension, and I'm going to do 18 divided by 2.94 for that dimension. So this was 8.1. 12 divided by 2.94 is 4.0 ... And 18 divided by 2.94 is 6. What is it? 1 ... So I'm looking at my 20. I'm looking at my base. So what I'm going to do is just the way my brain works. I'm just going to look at the floor. If I'm putting baseballs in a box, I'm putting them on the bottom of the box. I'm just going to draw a rectangle. This is my 24 by 12. And the 24, I can fit 8 of them. 1, 2, 3, 4, 1, 2, 3, 4. And the 12, I can do 1, 2, 3, 4. So that's going to be my base layer. And then I'm going to have 1, 2, 3, 4, 5, 6 going up. So how many base balls am I going to have? Well, I'm going to have 8 by 4 by 6. And that's going to give me 192 base balls. So I did another question like this. So you're putting something on a shelf. I would draw out, a cross section of it. I would draw out the base of it. I would divide to see how many are going to fit. I would do this little visual representation. That's what works for me. But it's come up multiple times now, so it's something that we want to make sure we're prepared for. Now, again, I know I'm going to have to do volume. So now that I did all that, it wants to know the weight. So whatever. Before I can do weight, I got to start with volume. So bowls are spheres, so it's V equals 4/3 pi r cubed. 4/3 pi, the radius is half of the diameter, so I'm going to cheat off of my sheet here, 1.47. I'm just dividing the diameter by 2. Cubed. That's giving me 13.3. ... cubic inches. Now that I have that, let's just, I'll put it here. I'll start my unit analysis. So I have 13.3 ... cubic inches. That's the volume of one baseball. I want to get rid of inches. I'm going from inches to pounds. 0.025 pounds is 1 cubic inch. I'm frozen. And I'm back. Let's take the opportunity to go purple. So I got my cubic inches gone. I've got pounds. I want pounds. Is there a quantity? Yes, the whole point of this problem, there's a quantity of 192. So I'm going to multiply by 192. I'm going to pop that into the calculator, and I'm going to get 64 pounds. So for these problems, you're always finding volume. But this whole shelf box thing is becoming a thing, so that's how I would deal with it. Okay, so which brings us into the next unit. Completing the square with circles. If I want to find the center and radius, I need to complete this square. And I'm frozen. Am I frozen? Yeah. Not frozen. So I'm going to write all my x's together, all my y's together, and all constants go to the other side. So in this case, everything is in the proper form. Time to complete the square. So I'm going to add my big blank square for my x's and for my y's, and I'm going to add that big blank square to both sides. So basically, this square corresponds to that square, and this square corresponds to that square. To determine what goes inside my big blank square, it's b over 2 squared, where b is the value in front of the x or the y. So for the x's, it's going to be 6 over 2 squared, which is 3 squared, which is 9. And for my y's, it's going to be negative 4 over 2 squared, which is negative 2 squared, which is 4. So 9 for the x's, 4 for the y's. Next, I factor my trinomial. It will always be the same factor written twice, and it will always be the square root of the perfect square. Combine like terms on the right-hand side, that's 36. Rewrite that as a binomial squared. Rewrite the y's as a binomial squared, and I'm in center radius form. Now that I'm in center radius form, to find the center, I always negate what's in the parentheses. So my x-coordinate is negative 3, my y-coordinate is 2, and the radius is always the square root of the right-hand side, which in this case is 6. If this is too much for you, I literally learned something today that might work for you. If you can't do this algebra, but I'll say that for another time, but let me know, because there is an little trick we can do in the calculator to help us with these questions as well. This brings us to the equations of line unit. Line dilations parallel keep the slope. No matter what, the slope is always, 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 always the same when I'm dilating a line. So the original has a slope of 3 over 2. So mine will also have a slope of 3 over 2. Now there's a shortcut that we can do for these, and then there's a not so shortcut. Let's do the shortcut first. Origin multiply scale factor and b. If it's centered at the origin, we're multiplying the scale factor in b. Just like earlier, when I dilated a shape, when it was centered at the origin, I multiplied the scale factor in the coordinates. For line dilations, I'm multiplying the scale factor in b. So my original b is -4. My scale factor is 3 over 4, -3. My m always stays the same. My m is 3 over 2. My b is -3. That's my answer. So if the center of dilation is the origin, I'm multiplying the scale factor in b for my new b, no matter what, my slope stays the same. Here's the cheat. If the center of dilation is not the origin, it's going to be the same thing. Now, I can't say that with 100% certainty, and if it's open response, you have to understand why. So let's go back to the song. Line dilations parallel keep the slope. I know no matter what, my slope has to be -3. Center on the line sub x and y. I have to determine if the center of dilation is on the line. I'm going to replace the y with 6. I'm going to replace the x with 0. And if the equation works out, the center is on the line. And if the center is on the line, the image is going to be the same as the original. So the shortcut, no matter what, the slope stays the same. If the center is the origin, you're multiplying the scale factor and b for your new b. And if the center is not the origin, that's your answer. But there is more stuff you have to understand about it, which we kind of talked about. For something like this, the line is dilated. So again, line dilations parallel keep the slope. It says that it's centered at the origin, but it doesn't tell us the scale factor. So the only thing I know if the line is being dilated and I don't know the scale factor, I know that the slopes have to be the same. And that's the concept. I need to see which one has the same slope. So I'm going to get this into slope-intercept form, since all the choices are in slope-intercept form. The slope of my original line is 3/4. So the slope of the image must also be 3/4. It says which linear equation could represent its image. Again, I have no idea what the y-intercept is going to be, but I do know that the slope has to be the same. So line dilations, always parallel, always the same slope. The little cheats, if it's centered at the origin, multiply scale factor in b. And if it's not origin, this is going to be your answer. However, what you should be doing is substituting the center of dilation into the equation to determine if it's on the line. If it is on the line, same y-intercept, same slope, same equation. And if it's not on the line, they don't have a different y-intercept. But they'd never asked you to write the equation when it had a different y-intercept. Now, dilating a line segment or dilating a shape. To find the length of a segment, I didn't even put it on here, but to find the length of a segment, you're just going to multiply the scale factor by the original length. For perimeter, it's the same thing. Perimeter is the scale factor times the original perimeter but the area is the scale factor squared times the original area. So the original perimeter was 20. The original area is 15. The scale factor is 4. So for the perimeter, I'm multiplying the original perimeter by 4. I get 80. For the area, I'm multiplying by the scale factor squared, which is 15 times 16. Use a calculator if you need to. 240. So for perimeter or the length of the segment, I'm just multiplying the original by the scale factor. But for the area, I'm multiplying by the scale factor squared. We have our slope-intercept form, y equals mx plus b, and we have our point-slope form. Your go-to in this course should be your point-slope form, which is y minus y1 equals m, x minus x1. That should be your go-to for writing the equation of a line. If it asks for the equation of a line, y minus y1 equals m, x minus x1. Now we need to know a little bit about parallel and perpendicular. Parallel has the same slope. Perpendicular don't. Perpendicular lines have negative reciprocal slopes. So, you need that information for this lesson, negative reciprocal slopes. If it says parallel, the slopes are the same. If it says perpendicular, the slopes are negative reciprocals. So since it says perpendicular to this line, I know that it has to be the negative reciprocal. So if the slope of this line is negative 3, then the slope of my line is the negative reciprocal of that, which is 1/3. I then need my x1 and my y1, which are the coordinates of a point passes through. x1 is 3, y1 is negative 1, and then I'm just going to substitute those values into my point slope formula. Y stays y, and minus in a formula means change the sign. So if it's minus y1, it means change the sign of y1. If y1's negative 1, I write plus 1. M is 1/3. X is x. Minus x1 means change the sign of x1. Since x1's positive 3, I write minus 3. That's your answer in point slope form. If it's open response, you're done. If it's multiple choice, you might see it in point slope form or slope intercept form. This one has them in slope intercept form. So the rest of the song might have to distribute. And I, so, late, y. Distribute. Use the calculator if you need to. 1/3 times negative 3 is negative 1. And I, so, late, y. And there it is. So your go-to for an equation of a line is y minus y1 equals m, x minus x1. Pop your values into that. You're going to have to use your parallel and perpendicular slope definitions. Parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Once you have those values, just pop them into the formula. And minus in a formula means change the sign. So you're always changing the sign of the coordinates that you have. I think I gave another one here. Same thing, equation of a line. Y minus y1 equals m, x minus x1. Parallel. Parallel lines have the same slope. This one's a little annoying because y is not by itself, so I have to do a little bit of algebra to get it by itself. So the slope of this line is negative 3/2. So since it's parallel, the slope of my line is going to be negative 3/2. In the last problem, I wrote m perpendicular because it was perpendicular. In this problem, I'm writing m parallel since it's parallel. x1, y1 are the coordinates of the point that it passes through. 2, negative 1. I pop the values in. Minus y1 means change the sign of y1, so this becomes plus 1. M is negative 3/2. X stays x. Minus x1 means change the sign of x1, so I put minus 2. I'm in point slope form. My choices are in point slope form, so no need to distribute or combine like terms. Look carefully. I want my negative 3 over 2 slope. That's 2 over 3. That's 2 over 3. Choice 1's your answer. Perpendicular bisector. Negative 4, 3, 4, 5. Well, let's break that word down. Perpendicular, negative, reciprocal, slopes. And a bisector, since a line is being bisected, it's being hit at its midpoint. So for perpendicular bisector, I need to find slope, and I need to find midpoint. So I haven't done that within the video yet. If you don't know how to find slope or midpoint, well, I'm going to go over it. But if you need more help, just find my video on slope and midpoint. I do delta y over delta x. I count. 1, 2 is my delta y. 1, 2, 3, 4, 5, 6, 7, 8 is my delta x. That reduces to 1 over 4. My midpoint, x1 plus x2, is negative 4 plus 4 over 2. My y's are 3 plus 5 over 2. That's 0 over 2, which is 0, 8 over 2, which is 4. You could also just kind of like count in the graph. If it's up 2 and over 8, it'll be up 1 and over 4. Either way you come up with that. So now that I have my slope and my midpoint, I don't want the slope of that line. I want the slope of the perpendicular line. So M perpendicular is going to be the negative reciprocal of that, which is negative 4. X1 is 0. Y1 is 4. Y minus Y1 equals M. X minus X1. Y minus 4 equals negative 4. X minus 0. A little too blended there for me. And that's it. You can leave it like that. If you wanted to put it into slope-intercept, you can distribute. Really not much to distribute there. And isolate y. Either one would be fine. If this is a multiple choice question, which it probably will be, a strong suggestion, just use the graph. I know that it's going to look something like this. So if it's multiple choice and it's got like y equals, you're going to see some 1/4s and you're going to see some 4s. I don't know, x plus 4 minus 3 plus 4 minus 3. Does this thing have a positive slope or a negative slope? It's got a negative slope. Is the y-intercept positive 4 or negative 3? It's positive 4. So if you put this onto graph paper, you don't have to do any of this. That being said, last time I saw one of these, like one of the slopes was like negative 4/3 and one was negative 3/4. So that's not foolproof, but that's something that might make this problem a lot easier. But if you're going to do it the right way, for perpendicular bisector, perpendicular negative reciprocal slope, so find the slope. Bisector hits at the midpoint, so find the midpoint. Do the negative reciprocal of that slope that you found, and pop those values into your point slope formula. Directed line segment, ratio, partitions. A lot of teachers do this a lot of different ways. I do it the way that I do it. I think the way I do it's best, or else I wouldn't do it the way that I do it. I is negative 7, 8. Q is negative 1, negative 4. Start with delta x over p and delta y over p. P is the total number of partitions, so if it's being cut in a ratio of 1 to 5, we add those. P is 6. The delta x, I count. 1, 2, 3, 4, 5, 6. Delta y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could also subtract to come up with those values, 1 and 2. So now I'm going to count 1 in the x direction, 2 in the y direction, and make a point. 1 in the x, 2 in the y. I keep on going until I end up at the other endpoint. IQ means I'm starting at I. I is 0, which makes this 1, 2, 3, 4, 5, 6. So which one is the answer? Whichever one comes first in the ratio. 1 is written first in the ratio. 1 is the point you're looking for. The coordinates of that point looks like negative 6, comma 6. Every single region, if they ask one of these, if you know how to do it, you're great. And if there's no graph paper, use the graph paper attached to the back of the exam, okay? It's there for you. If your teacher says, well, I'm not going to give you graph paper, well, your teacher's not very good at teaching geometry, because geometry is all about using the graphs and the pictures and the shapes. Just use the graph paper attached to the back of the exam. Area. This used to be a once in a while thing, but this is becoming every exam at this point. So to find area on the grid, we use our box method. And our box method starts by putting a box around our shape. So I'm going to put a box in all these corners to create a rectangle. I'm going to use the line here to be precise. Now I'm going to start by finding the area of the rectangle. The area of the rectangle, I'm going to count. So this is 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I like to break it up because later on in the problem, it'll be nice to have it split up. So the rectangle is 10 by 8, which is 80. Now I'm going to find the area of each of the triangles. So I'm going to write area triangle 1. Let's call this one triangle 1. Triangle is 1/2 base times height. 1/2, 8 times 6 is 24. I'd like to put into the picture. Area of triangle 2, let's call this one triangle 2, is 1/2 4 times 3, which is 6. And area triangle 3 is 1/2 10 times 5, which is 25. Now I'm going to add up all the triangles. That is 55. And I'm going to subtract that from the rectangle. Did I do something wrong? 25, 24, 6, 55, 80. No, 80 minus 55 is 25. That's your answer. Because basically, if I find the area of this whole thing, and then I take away this triangle, and that triangle, it leaves me with what I'm trying to find. Which brings us to our circle rules. Let's just talk about our big four. We've got arcs and angles. We've got segments. 2EA equals major minus minor. 2VA equals arc plus arc, and 4 segments. Use P, P, and we. These are your big four. 4 arcs and angles. If there's arcs and angles involved, we're using 2EA or 2VA. 2EA is major minus minor. 2VA is arc plus arc. If there's segments involved, then it's PP, we, part times part equals part times part, whole times exterior equals whole times exterior. So we'll get into one of each of them shortly. All right, so let's put the information into the picture here. Let's see if I can just blow this thing up. I got RPS is 35. I got RS is 121. I got WT is X. So arcs and angles or segments? I see arcs and angles. These are arcs, angles. So it's going to either be 2EA or 2VA. EA stands for exterior. Is there an exterior angle? Yes. So it's going to be 2EA equals major minus minor. The exterior angle is 35. The major arc is the bigger arc. That's 121. The minor arc is X. I do a little bit of algebra. And I get my answer. The math is simple for these. It's just knowing all your little rules. And that's why the songs are going to be helpful. Put an X on what you're trying to find. Angle ABC. Arcs and angles. Angle, arc, arc. So it's going to either be 2EA or 2VA. Is there an exterior angle? No. Is there a vertical angle? Yes. So it's 2VA equals arc plus arc and vertical angle is X. Arc plus arc, 36 plus 20. Doesn't matter which one goes first. Simple algebra. X is 28. RS is 6. ST is 4. RP is 15. RQ is X. Arcs and angles or segments. This is a segment. This is a segment. This is a segment. This is a segment. These are segments. 4 segments. I'm frozen. Am I frozen? Yep. All right. Lost where I was there. So we don't have arcs and angles. We have segments. So 4 segments. Use PP and we. Those are your 2 segments rules. PP, we. The E stands for exterior. Do I have an exterior piece? Yes. So it's we, which is whole times exterior equals whole times exterior. So let's start with the secant. The whole secant is 10. The exterior piece is 6. The other secant, the whole piece is 15. And the exterior piece is X. A little bit of algebra. 60 equals 15X over 15 over 15. 4 is X. If you had a tangent, the whole is the exterior. So just be aware of that. If you have a tangent in a secant, let's say this is X, the whole would be X and the exterior would be X as well. Either way, it's always whole times exterior equals whole times exterior. BR is 10, BE is 4, AE is 8, ES is X. Arcs and angles, no. Segments, yes. 4 segments. Use PP and we. Do I have any exterior pieces? No. So it's PP, which is part times part equals part times part. So it's the 2 parts of the same chord that are being multiplied by each other. So for BR, this part's 4, the other part would have to be 6, since the whole is 10. So for BR, part times part is 4 times 6. For SA, part times part is X times 8. 24 equals 8X, divide by 8, divide by 8, X equals 3. So those are your big 4. Now, this is nothing new here, but there's sometimes some twists on it, so this problem will have a little bit of a twist, including having to draw your own picture. This is where vocabulary is very helpful. Understand that this is a chord. This is a tangent. And this is a secant. I feel like knowing that vocabulary makes it a lot easier to build the picture here. And the picture is really not so bad to build as long as you know the vocabulary. Diameter ROQ of a circle. So I'm going to draw a circle nice and big. I'm going to draw a diameter. There's my O. RQ is extended through Q to point P. So it's going through Q to point P. And tangent PA is drawn. So I'm going to draw a tangent, and that's going to be A. There it is. I have my picture. Arc RA is 100. It wants angle P. Arcs and angles are segments. These are arcs and angles. So it's 2EA or 2VA. It's 2EA. 2EA equals major minus minor. Problem is, I don't have the minor. So I have to use a little bit of geometry to get the minor. In general, with circle problems, I always say look for inscribed central radii diameters. Well, I've got a diameter. A diameter cuts a circle in half so that each half is 180. So if that's 100, that's 80. So it's 2 times x equals 100 minus 80. 2x equals 20. And I got a small little angle of 10. Very obscure rule, very simple rule. When I have a quadrilateral inscribed in a circle, the opposite angles are supplementary. So this angle and this angle are supplementary. So 80 plus y plus 30 equals 180. And these angles are supplementary. 75 plus x plus 10 equals 180. So I do some algebra. X plus 85. 75 plus x. Oh, minus 10, excuse me. X plus 65 equals 180. Minus 65 minus 65. X equals 115. And for the y's, y plus 110 equals 180. Minus 110 minus 110. Y is 70. Area of a sector. Area of a sector. Theta pi r squared over 360. Might be my favorite song of all my songs. Yes, I have favorites of my own songs. This has come to that point. It's asking for the area. Theta is the central angle in degrees. Radius is half of the diameter, which is 5 over 360. It's the nearest tenth, so we are typing pi in. We pop that into the calculator, and we get, I believe, the answer was 6.5. Area of a sector. Don't forget SOR for arc length. For arc length, length of an arc, SOR, where S is the arc length. Theta is the central angle in radians, and 95% chance it'll be in radians. And for that 5%, well, you can talk to me about that another time. R is the radius. S is 10, theta is pi over 2, R is x. I want to find x. It's easiest, just divide by pi over 2. alpha y equals enter, 10 divided by alpha y equals enter, pi over 2, 6.4. Area of a sector, every single region as I ask. SOAR, not so much. It does not come up often. It has come up a few times, but it is not a very commonly asked question. All right, let's get into these quadrilateral properties. Part of me wanted to cut it here and include these in with the proofs because a lot of the proofs deal with the quadrilateral properties, but we'll talk about it here. Let me pull up something. All right, so this is what you need to have memorized, and you need to understand how these all relate to each other. The 5 ways to prove a parallelogram. 4 of them deal with opposites. Let me just get my pen tool back up. Oh, get me out of here. No, 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 no. All right, that was scary. So 4 of the 5 deal with opposites, 2 pairs of opposite sides congruent, 2 pairs of opposite sides parallel, 1 pair of opposite sides congruent and parallel, 2 pairs of opposite angles congruent, and then all 3 shapes have at least 1 diagonals property. For a parallelogram, diagonals bisect each other. The rectangle, diagonals are congruent. Rhombus, diagonals are perpendicular and bisect the angles. The other way to prove a rectangle is the right angle. And for a rhombus, consecutive sides are congruent. So, all of these things are parallelograms. Parallelogram has all of these properties over here. From there, if I want to, so let's talk about properties first. So a parallelogram has these 5 properties. A rectangle is a parallelogram. So a rectangle has these 2 plus these 5 has 7 properties. A rhombus has these 3 plus these 5 has those 8 properties, and a square has all 10 of them. Now, let's talk about how to prove the different shapes. To prove the shapes, to prove a rectangle, I need to first prove that it's a parallelogram, and then I prove it one of these 2. To prove a rhombus, I first prove a parallelogram, and then I prove one of these 3. And to prove a square, I first prove it's a parallelogram, then I prove it has one of the rectangle properties, then I prove it has one of the square properties. So we're going to focus mainly on the properties right now, and the how do you proofs, we'll kind of keep that more for proofs. So let's get back to this. Given 3 distinct quadrilaterals, a square, a rectangle, and a rhombus, which quadrilaterals must have perpendicular diagonals? Well, you need to know that perpendicular diagonals is a property of the rhombus, and a square has all the properties of the rhombus as well, so that would be your answer. Then we get into doing the angle stuff with it. With these questions in general, we want to always look for linear pairs, and angles of a triangle. Other stuff is important as well, but they'll give it to you. Those are the 2 things they won't give you need to look for. This they're giving you. That is very important. Whenever you see 2 sides congruent, we're going to mark the sides. We're going to mark the angles opposite them. So if AF is congruent to DF, then those angles must be congruent. If it's a parallelogram, I know that the opposite angles must be congruent. So if angle R is 124, then angle D is 124. Well, now that I have that, I see a linear pair. So 180 minus 124 is 56. If that angle's 56, then this angle's 56 because I already marked that they're congruent. And now I have angles of a triangle, 56 plus 56 plus x equals 180. 112 plus x equals 180. Minus 112 minus 112, x is 68. So parallelogram has opposite angles congruent. That's the property that would apply for these types of questions. When you have two sides congruent, mark the sides, mark the angles opposite them, and look for linear pairs and angles of a triangle. Bisect is another thing that's been coming up more recently. If AE bisects angle BAC, that means that this angle is bisected, which means that those must be congruent. Altitude BD is drawn. Well, an altitude creates right angles. Angle C is 50. Angle ABC is 60. What is the measure of angle FEB? So it's looking for this. To get started, look for linear pairs, look for angles of a triangle. The only thing I see right now, I see the big triangle. I have two angles, 60 and 50, so I can find the third. X plus 60 plus 50 equals 180. X plus 110 equals 180. Minus 110 minus 110, x is 70. I'm cutting that in half, 35, 35. Now, I'm only one step from the end. It's asking me for that green angle, so I see this triangle where I have two angles and need to find the third. So I can do 60 plus 35 plus x equals 180. 95 plus x equals 180. Minus 95 minus 95, x is 85. So these are not easy. They could be easy, but they're not, depending on the problem. But you want to always look for your linear pairs, look for your angles of your triangle, understand what to do when you see bisect, and understand what to do when you see that two sides are congruent. And that's it. We made it through. If you're following along in the packet, there is more. There's proofs, but we're going to save proofs for another time. You know what we're going to do? We're going to do one more question now. So it's all proofs, 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 proofs. And there's one question at the end. In fact, you know what? Let's not do it because I don't have it up on my screen right now. Actually, yeah, let's get it up on my screen. Give me a moment. And what's important for this question is you want to always look for hidden right triangles. There'll probably be a hidden right triangle somewhere on your exam. So this is just an example of a hidden right triangle. So we did this earlier. We did 3D rotations. We're doing it again. We want to continuously rotate this triangle around side BC. So I connect it in 2 dimensions. I reflect it in 2 dimensions. I connect it with curves. I've got a cone. I do v equals 1/3 pi r squared h, and the problem is that I don't have the height. You need to just be able to look for hidden right triangles. I see a right triangle here. I have 2 sides. I want to find the third. When that happens, that's when I use Pythagorean theorem. This will probably come up somewhere. It could be in a question like this. It could be in a question completely different. 9 squared plus b squared equals 14 squared. 81 plus b squared equals 196. Minus 81 minus 81. B squared equals equals 115. Square root radical 115. Now that I have that, v equals 1/3 pi. The radius is 9. The height is radical 115. You pop that into your calculator, and we get 909.6. So I just made a separate lesson on this because you're probably going to see it somewhere. I can't say where you're going to see it, but you want to always kind of, if something's missing, look for a hidden right triangle. You might have to do Pythagorean theorem. So that's it. I mean, I'm going to be a little vain here. I think this is the most important video that exists to help you prepare for the Common Core Geometry Regents because it's all the commonly asked questions in one video. I'm not going to run through it again now. You have it, pause it, do whatever you need to do with it. You have all my keys and packets on Schlansky.com. You have all my videos on Schlansky.com and on my YouTube channel. Use them, ask me questions, and that's all I got for you. I will hopefully be back with the proofs version of this, but for now, that's a wrap. You made it to the end. Practice time. See ya.